Hello, my name is Madison Sardine, and this is my presentation on atomic theory. Before we begin, let's have a quick overview of the topics we'll be covering in this presentation. First, what is atomic theory? Second, the origins of the atomic theory. Third, the evolution of atomic theory. And fourth, modern atomic theory. What is atomic theory? First, we have to understand that there are several forms of matter: liquid, gas, solid, and plasma. Atomic theory seeks to explain what is the stuff that makes up matter, what is the structure of this stuff, and how does this stuff function. Well, to begin, we'll have to explore the origins of atomic theory. In 440 BCE, Democritus, student of Leucippus, I'm sorry if I mispronounced that, had theorized that all matter is made up of small unbreakable particles varying in size and shape. These particles he called atomos, which is Greek for indivisible. This was purely theoretical, and it was a blind guess of if you divide something in half enough, it eventually would be indivisible. Well, this idea did not stick because it was completely opposed by Aristotle, who was a great scientific mind at the time and theorized that all matter was made of the four elements: earth, water, fire, and air. This would continue to be a thought until the late 1700s, when Antoine Lavoisier made his law of conservation of mass. As matter changes shape, its mass will remain constant. John Dalton, in 1808, challenged atomic theory and proposed that common substances will always break down into the same element in the same proportion. He basically found that substances were combinations of elements, and these elements were made out of atoms. And now that they knew that atoms were a thing, they had to figure out what the structure was and how they worked. J.J. Thomson decided to run with this and did cathode ray experiments in the 1800s. J.J. Thomson is responsible for making the plum pudding model after the discovery of electrons. Electrons were shown to be negatively charged, so he had them sort of stacked like pieces of plums inside a cake of positive charges, as can be shown in the model on the right. J.J. Thomson also discovered that atoms can be divided. Then in 1909, Robert Millikan and Ernest Rutherford both performed their respective experiments. To begin, Millikan had his oil drop experiment, in which he discovered, after running oil through two charged plates, the charge of the electron. And Rutherford's experiment was the gold foil experiment, as can be seen on the right. Rutherford shot small alpha particles through a thin sheet of gold foil. Rutherford had expected the alpha particles to punch right through the foil, with the positive charge of the foil not being strong enough to withstand the alpha particles' positive charge. Instead, he found that the alpha particles had bounced all over. Most of them had gone straight through, but some of them did not. And this led him to discover these findings. There is a small positively charged nucleus in the center of the atom, and most of the atom is space. Niels Bohr continued the work by creating the planetary model. He utilized the work of Albert Einstein and Max Planck to show this model of a nucleus in the center with electrons orbiting around it at specified distances. The amount of electrons orbiting the nucleus could be determined based on the element that this model is portraying. Werner Heisenberg in 1927 utilized the work of Louis de Broglie, again I'm sorry for my pronunciation, with who theorized that atoms have wave-like movements of their particles, and Erwin Schrödinger, who made Schrödinger's equation, described the wave-like movements mathematically. He utilized these works to create his uncertainty principle. The uncertainty principle stipulates that the surer one is of the momentum of a subatomic particle, the less sure one is of its position, and vice versa. He also played a huge hand in proposing quantum theory and the fact that orbitals exist, as we'll see in the next slide. The latest and final piece to the puzzle of atomic theory, for now, came from James Chadwick, who discovered neutrons in 1935. With that, we were able to create this model, the electron cloud model. It shows the orbitals, the fact that atoms have orbitals, and in the very middle of this orbital is a little nucleus filled with protons and neutrons. Modern atomic theory today has the cloud model being the most current model. Atoms are comprised of some atomic particles, which are, for now, protons, neutrons, and electrons, positively, neutrally, and negatively charged, respectively. Atoms are divisible via nuclear fission, and the particles of atoms are both wave-like and particulate. We have much to learn about atomic theory, and we are far from being done. So, I'll show you my sources and claim that this is the end for now. Thank you so much for watching and for your attention to this presentation.